Good morning, everyone. Thank you for joining us this morning on another Meetup talk on this time on DevOps in the age of AI. Again, my name is Aziz. I'm one of the hosts here on the Ubuntu TechHive. For those who's the first time joining, we've been doing this for a year and a half now. We have all of our recordings, all of our documentation on the website, which I'll drop the link very soon. So here, this is the Meetup page on where you can, if you hear, that means you probably saw this page and you signed up for it. This is where we post most of our talks, not the talks themselves, but the actual meeting overview. We also have a Discord and a WhatsApp group. If you want to join those as well, we'll drop the links in the chat. We also started another project not long ago that I'm going to share the link. So basically, it's called Ubuntu Code Cafe. So basically what this is, it's just kind of like Ben and I, and hopefully some of you as well very soon, discussing technical things and technical stories, but not showing code, not talking, showing any sort of infrastructure. It's mostly just conversation and takes and opinions and ideas. So it's a YouTube page. So if you get a chance, you might want to also take a look at those. And obviously, if you have any comments, please do so. If you have any feedback, please do so. If you also want to maybe join us one of these days to have a conversation, you're most welcome. The only thing is that we record these usually either Sunday morning or Sunday night. So, but we can always work with you. So that's that. So before we get started with Ben, who's going to present DevOps in the age of AI, I'm curious to know, like, what are the folks in the audience that I would say are DevOps engineers or have dabbled into DevOps, and if you can maybe share what you're hoping to get out of this presentation. So you're more than welcome to unmute yourself and share your thoughts. Or if you have never done DevOps, that's okay too. But what's as you saw the title, what are you trying to get out of this talk? Pretty much. So the floor is open. Just gonna take a few minutes to do that. No one? Nobody is in DevOps right now. Nobody is a DevOps engineer or has dabbled into DevOps.
Yeah, geez, good morning. So this is Deep, and I'm actually, yeah, hi. I'm the DevOps engineer, and actually, I'm looking forward to know about more about the how the AI plays the key role in the DevOps. Like, you know, um, recently my project got ended, and when I'm taking the calls, like most of the people are talking about the MLOps and the AI related things they're actually want to improve in their web applications or in the mobile applications through the DevOps. So I'm actually curious to how the roadmap should be, for the DevOps. Like we have a roadmap. Like first you need to like learn the Linux and GitHub, and like for source code, you have a one of the sources, and for the configuration management, and also for the infrastructure, for every aspect there's gonna be a tool, and we can at least we should learn one of the tool. But when it comes to the AI, actually I'm not able to find out the roadmap and how it gonna help for the DevOps engineer.
Yeah, that's a very good point. And I mean, my take, to kind of give you a little bit of background. I am more of a cloud engineer, data engineer type person. I've done some DevOps, mostly Microsoft. I forgot the tool now, but mostly on the Microsoft side of the things, right? So my personal take is that maybe because AI is so kind of like new, or I would say even there's hype, but a lot of people are not really pushing towards like the DevOps side of things. They're mostly like on the I would say model serving, or things like ChatGPT and stuff. So the companies themselves, like the OpenAI and the big companies actually serving the models, for sure, they probably have robust DevOps, in order to serve these machine learnings like to the public, right? But companies themselves, because they themselves may not be serving models or this type of model, they don't necessarily, how do I say that, focus too much on that side. So, but it would be good to see like what Ben has found out, and see how he incorporated AI into maybe some DevOps steps or DevOps tools. Yeah. Thanks for your comment, Deep. Anybody else?
Thank you.
I'm aware of the different concepts when it comes to DevOps, but I mean, I can deploy basic apps. So for me, I'm looking for simplicity. See, because I noticed when I started at learning about DevOps, I noticed that it's more suitable for larger companies. Sometimes it was like it's overkill, right? If small company, you might be tempted to use something like Heroku, right? Just write your application and you push it. Very simple. But it's like every time I was trying to use DevOps, it's almost like it was making things more complicated. For simplicity. So hopefully you'll be able to show something. I mean, our AI, I hope it's going to simplify the process.
Well, we're putting pressure on Ben now. It's funny you talked about sometimes using some tools for your personal project that may not be suitable for like a small project. They're mostly for like enterprise, right? In one of those talks that we had, we talked about how sometimes putting everything in the cloud or using all the cloud services actually hinders your progress or costs you money for nothing. Just an example could be instead of maybe using the build tool from the cloud provider, if your application is not big enough, or if you're able to build on your computer, just build on your computer and then deploy it or upload it to the server on the cloud, right? So you save that build time or that instance time, like from a cloud provider, for example. Yeah, we talked about like things like that in one of those Ubuntu Code Cafe. I can't remember which one it is, but I think it was 2 or 3 weeks ago. Yeah. I don't know if there are any other comments. I don't see any other comments, but yeah, pretty much this is the gist of it. So we have a Ubuntu Cafe if you want to go watch those videos, and then today we're talking about DevOps in the age of AI, and presenter today is Mr. Ben. So take it away, sir.
So, hello everyone. Can everyone hear me? Okay.
Yep.
Okay. So let me share a couple of links first before we start. So let's see. Okay, share this one. Okay, so as you can see, I didn't take much notes because today I anticipated the meeting to be more interactive than usual. I've tried to prep as much as I could, given the time that I had to get ready, and basically during the presentation and demo, my expectation is that you also jump in with your inputs, and if you have questions that I can answer, like feel free to interrupt anytime. Yeah, does it sound okay?
Yep.
Okay. So, you have a question?
No, I just said sure.
Oh, okay, no problem. Okay, so let me see. Okay, so the presentation for today is DevOps in the age of AI. So by training, I'm a software engineer that wears different hats. So some of my time is spent writing new code. Some of my time is spent doing some DevOps tasks and so on and so on, even UI at times. And so what I've been noticing since all of this, since AI has been picking up in the last couple of years, is that I've always had the feeling that we always have to use some software as a service platform, which is paid, in order to have access to models or, to play around with them, right? And during that time, the closed source models are obviously ahead, but there's a number of open source models as well that are catching up fast, especially when we go small, right? So some of those open source models which go small allow us to deploy some LLMs onto small devices like Raspberry Pi, like cell phones, or even tiny virtual machines that we run ourselves, right? So my exploration was to figure out how to match this new area to something that we have pretty much been doing for quite a long time as part of software engineering and DevOps. Let's see. So, so this presentation is almost like a part 2 to a presentation I made earlier this spring, and the presentation was model packing and shipping. So I'm gonna share that link. I'm gonna share that link and do a quick recap so that you are all situated. Okay. So if you go to that link, I added some visuals to help explain what's happening. So essentially, in the first presentation during the spring, we went over how models are trained, the workflow, how models are trained, and how do we get them into a file, which represents all of the weights and basically the neural network itself. How do we serialize it to disk into a file that we can then deploy depending on the requirements? And basically the workflow is as is. So let's assume you have a Jupyter notebook. Let me pause for a second. But when I say model, I just want to be clear. Classical machine learning techniques can yield a model. it's not going to be 2 billion parameters. It can just be a few hundred or even less, right? So the technique goes from small to really big, right? So during the training, let's assume you have a Jupyter notebook on Google Colab. You can write a little bit of PyTorch or TensorFlow, run the training steps, and then at the end of it, usually that's where people stop with the model being trained and the values of the model just being kept into memory, so that if they go ahead and shut down the instance of the Jupyter notebook, it's pretty much gone, and they have to go back and then train again in order to get it. So after the training, there's another step to actually get a file, which is saving the model, right? And when we save the model, there are different file formats available. So for example, on TensorFlow, you have the H5 model, H5 file type. For PyTorch, you have a .pt file. Or if you are using Python, you can simply pickle the model. So what it's going to do, what this process does when we save, it basically takes the in-memory model, it takes the in-memory representation of the model and just serializes it to disk, which is no different, for example, for those who work with JavaScript and make an API call, let's say, and receive some JSON back. So the JSON has the in-memory representation, which can be stringified so that we can print it to the console. So it's the same process. And if you look into this repo, I have a couple of notebooks just to show you how it works. Okay, so in here, this notebook was a simple example of the very popular Iris dataset. Basically, the training of the model here has to do with trying to predict what type of flower we have based on some inputs. So as you can see, the model is defined with some dense layers, and then it's compiled. And then this is where the training happened. We feed the model, and then we print the accuracy, right? So it's set up for 100 epochs. So those are the training steps. And then after completion, like we can see how the model performs against some test, some test data set. And let me see why I'm not saving this one. Okay, so this is the part that I was telling you about earlier. The model here, this variable, is the one we saw here. It at this step here on step 10, it only exists in memory, right? So if the machine was shut down at that point, the model would just be gone. So in here, when we do that save, it actually gets serialized to disk, right? And then once it's on the disk, we can always restore the in-memory representation of that model from the disk image of the model that was saved. You know, so that's what's happening here. Since we saved it to disk, we can read it back out. So any question on this? Okay, so let's proceed. Let me see another notebook here. Okay, so here, this is just another example. In here, instead of TensorFlow, I was using JAX. And same thing, it has its own syntax with JAX to train the model. But then you notice that this time, I'm just using the pickle module from the Python library, and then I'll just write it to disk. So the file will be Jack's model iris.pickle. So it's just a file on disk that can be loaded, and then the restored model can be used to make some predictions. And the interesting thing is, once we serialize the model, we can then use it for, we can distribute it pretty much. So, and when we distribute it, we can actually load it like from inside another application to run the inference. So in here, I have a simple fast API project. And what it does is that when the application first loads, it loads that pickle file from earlier. It could have been the .pt file for PyTorch. It could have been the H5 for TensorFlow, and so on and so on. Right? So we load it from disk, and then at this point, the input parameter is usually an integer for this case. Like basically the row of the row in the data that represents a given flower, like that index will be passed, and then the app will pass it to the model to run the inference and then return the results. So here it returns the prediction. Any question on that? Okay. Yeah, go ahead. Okay.
There's a question from Srini.
Yes, go ahead, Srini.
Well, in the chat, it says, which one of the PyTorch, TensorFlow, and Pickle is efficient?
Well, it depends. I know that Pickle for sure will not be very fast, but again, it depends on the type of model. Here is just a tiny one, so it will be fast enough. It's not doing any heavy computations. There's not even a need for a GPU, right? So I think if you were looking to optimize something small like this, then you want to make sure that the model itself is loaded once and then kept in memory. That way you don't have to read from disk every time on every request. That can speed up the inference. But those models here that I have here are so small that I don't think it will make much difference. Usually the time is spent depending on the size of the model and the number of resources that it requires in terms of RAM and GPU. So, okay. Okay, so I just describe the model lifecycle, and this was at a small scale, a very small scale. The process for larger models like the GPTs and the llamas and so on and so on, it's essentially the same. I'm sure there are more complex things that go along, but from a high level, this is what represents the life cycle of the model, right? And there's also another interesting thing that happens in the space is that even though like each framework can produce its own file type, there's a lot of tools and a lot of open source like development to make sure that a model produced from one framework can easily be converted into another one. So here I gave the example of OnX. I think if I'm not mistaken, it's a project from Microsoft that basically lets you convert like PT and H5 to this model, and this one is portable across multiple frameworks and languages and tech stacks. So it's a more portable format if you want. Okay. So if you don't have any more questions on this one, I can switch to today's presentation.
You're good to go.
Okay, so let me close this. So this is the same graph I ported over. So let me see my notes here. So I was taking some notes earlier when you were you guys were having the discussion, and like I said earlier, my goal today was to try to leverage open source models that go small so that we can get to like add them to our smaller scale infrastructure, right? So I think the term that they use for that is being GPU poor. And there was also a mention that the documentation is a bit sparse in that space. So one of my other goals is to show that it's not that different from the regular software engineering practices that we have been doing. Okay, so let's start. Let's start with a tool. One of the tools that make it easier to get a hold of open source models. We have Ollama, which is very popular at the moment, and we also have Llama CPP. So those are GitHub projects. Yes, go ahead.
When you go back to the this one, if you don't mind increasing the font, the size of just slightly a little bit.
Let me see. Actually, hold on. Let me switch to the terminal because it doesn't let me increase it here.
Okay.
How is that?
Maybe one more. It's more for the screen too. Okay, this is good. That makes yeah. Thanks.
Okay, so we just went over this. Okay, so we have Ollama, like I was saying, and Llama CPP, which are open source projects. So let's take a quick look. Okay, so let me share the link. Okay, so if I have to describe Ollama simply, is that not only it lets us run in a straightforward manner, it lets us run open source models, but it's taking the approach of Docker. So if you are familiar with Docker, there's a lot of overlap between the Ollama tool and Docker, in the sense that we can pull models just like we do Docker pull. We can serve, we can run, we can do a number of different things. They even have a file format which is very close to the Docker file, that lets us, specify how we want to set up the model in order to run it. But on the local machine, it's pretty simple. I'm using a Mac here, so I can just do a bro install Ollama. I think I already did it. So bro install Ollama. I think it's already installed. Okay, storing a small update. Give it a second. Okay, so it's already installed. And once it's installed, we can directly pull a model. So in this case, I'm pulling, actually I have to run it first. So let's see. I think I have to do run. Okay, so I have to run it first. And then from that point, then a given model can be downloaded. So in this case, I just downloaded Llama 3.2, and I did it before. That's why it was so quick. But I think it's a couple of gigs in size, and then you can kind of see that the Ollama pool actually made an API call to the Ollama server, right? And it's a post request that contains if you want the payload to tell the tool which model to download, and it did. And then at this point, the model should be ready to serve. So if I go here, I created a small application. I'll call it, I created a small Ruby application to exercise the model. So, I did a bit of a hack here. It's actually a Rails app, but I shrunk it down to a single file. I usually do Python, but today I just wanted to change it a little bit. And then to actually invoke the model, I'm using this library here called Ruby OpenAI, right? So it's a client library that lets us invoke all the APIs which are compatible with the Open API spec provided by OpenAI. So what that means is that any open source model that implements that spec can directly reuse all the OpenAI clients, right? So in this case, both Ollama and Llama CPP implement that Open API spec. So let's take a quick look at the client.
Ben.
Yes.
Just so I understand. You're currently using an open AI, I don't know, like SDK or something like that, to talk to a different LLM.
Exactly.
Okay.
Yes. So you can see here, this is the actual Open AI client, right? And okay, I'm overriding some values. Like let's say like I'm overriding the URL as well as the API key, right? So I can show you my, let's see. I have to copy my API key. 1 second. Okay, so if you can see the name of my variables, you can see that I have the one for Grok, for example. Grok is another one that implements the Open AI Open API spec, right? And then since this is a cloud service, I need an API key. So that's what you see here, right? So it's picking up that API key and then overriding the URL to Grok. Grok / you can even see it in the part of Grok /OpenAI /v1. So it's implementing that spec. And then from that point on, I can run it. And then the interesting thing is, at the model level, instead of it being GPT-4 or like GPT-4.01 and so on, 3.5 and all that, I can specify 3.2. Okay. And then since those are modules, let's say, let me try the Grok one first, just to show you, since we were talking about that. Okay. So I have the Grok. It's set up for the Grok now. So, okay, so in here, I'm just importing that module. And then I have this endpoint here that accepts, that basically accepts the call from the client. So you can see that here it's implementing, it's instantiating the client, and then makes it available here, right? And then here I'm just making a streaming query, so that instead of getting the whole response at once, it's just gonna stream it a piece at a time, right? And then I just flush it to the client. I flush it part coming back to the client for display. So let me try running it and see. Okay, so the app is started. Let me see if we can zoom in. Okay, so let me refresh. Okay, so let me ask it a question. Who network tab, so you can see who are you? Okay, so you can see that it's responding with this. It's a Llama model. It's the Llama large language model from Meta AI, right? And then, like I said, it was streaming. You can see the responses like coming back progressively. Like the first chunk was I am an artificial, and then I keep appending to the original string, right? So you can see the text grow and grow until the whole response is complete. And what I'm doing on the UI is that I pick a div where to display it, and then I just override the inner HTML of the div so that we see the whole response here. Yeah, does it make sense?
Yeah.
What is the advantage of breaking it into chunks? Why are you reading it chunk by chunk?
Well, if you go to let's see, actually the advantage is that it's basically the main benefit, I would say, is for user experience. Because depending on the type of prompt or query that the user makes, it can lead the model to generate a whole bunch of text, which might take a while to produce, right? And the models themselves, like especially the fact that they have to do some heavy processing in order to produce the response, there's a latency attached to it, right? So instead of the client having to wait for the whole response to be complete and then get it in one shot, it's much better to see the first few words appear right away.
Got it. Okay.
And then in terms of, since we're talking about DevOps today, in terms of operations, if you have to buffer a very large response in memory, try to consider the case that you have many users, several users, like actually a whole lot of users on your, let's say on your chat application all at the same time. You know, all of those buffered responses in memory can actually eat up a lot of your RAM on your server. You know, so it's better to send it across, you know, right away. Here I'm actually buffering it, but what I should really do is to buffer it on the client side. But yeah. So those are the two main advantages. And also, if you go to ChatGPT or Claude or whichever one is your LLM tool of choice, you'll notice that they all do the same. You know, just to improve the user experience.
So I think you and I talked about this earlier this year. If I remember correctly, it also sort of mimics a little bit how we speak, right? You know, like we speak like you're hearing my words, they're coming like one at a time, right? Whereas I'm not like dumping all of my thoughts right in one go, you know, as like a block of sentence to you, right? So yeah, I think it kind of mimics also how we speak. Yeah.
Exactly. Exactly. Because I can imagine like watching a lecture maybe from a professor at school, and then the whole lecture just comes in all at once. So it's like it will be hard.
So the chunk message that you displayed on the network tab, right? Is it like is it based on the API calls that you're making? Are you making chunk API calls, or are you making one call and then you just appending the message in chunks?
Yes, I'm making one call and then appending the message.
All right, great. That's why I was asking the question, because I thought you were making like multiple API calls.
No, it's just one call. I can show you. What did I do? Let's see. Okay, so it's here. Actually, let me go in here. So this is the client. So the initialize is the constructor for the class. And you can see that it accepts two inputs. The messages. So the messages are a combination of the system messages. You know, the system message will be something like, you are an expert DevOps engineer who knows Terraform. I'm gonna ask you questions about Terraform, and then you will help me, something like that. You know, and then what comes after is your user message. So this is actually an array of both system and user messages. You know, just like the regular inputs for ChatGPT, for example. And then the proc here, this is a closure. This is a closure that will receive the stream, the response stream from Grok in this case, right? And then it's gonna loop over that response stream from Grok until it's fully exhausted. And as it goes through it, it flushes the messages back to the client. So if I go back to the controller, so this is that same method being called. Those are the messages. Those are the messages in here. And then this is the closure. You know, it starts here, ends here. Right? So it's getting one chunk at a time. And then for each chunk, I'm retrieving the basically the first response, which is usually the one that has the highest percentage in terms of being correct. And then well, once I have that partial response, I'm just buffering it into this buffer over here, right? And then on each iteration of that, of receiving that a new chunk from the LLM endpoint, I just use this SSE server sent event. and then I'll write it to the, I'll flush it down the connection to the client. Right. So let me see. Oh. So I think if we look at this, oh, I think it's already gone from there. But anyway, that's what's happening. So on the server side, it's doing this, and then on the client side, it's doing this.
I see. Yeah, thank you.
Okay. So I use the same pattern for the others. So here, this was broke. So I can switch to Olama now. So in the case of Olama, it's exactly the same structure. But in this case, Olama doesn't use an API key because we control it, right? It's a free model running on the machine. So the only thing that we have to do is to swap the URL to point to the Olama instance. And the Olama instance is this one. This one is running on port. It's hard to read here. Yes, so it's running on port 11434, which is the same thing that we have here. And then again, it's the same thing. It accepts a proc, the same proc that we saw, that goes over each chunk of the response from the LLM, and then flush it. All right. So let's try it out. Okay. So if I refresh, is it connected? Okay, so you can see that this time around, it's mentioning something completely different. It says I'm an artificial intelligence designed to assist, provide on a range of topics. I don't have a personal name. You see, earlier it mentioned that its name was Llama 3 from Meta AI. In this case, it says it has no name, right? And then some other facts about itself. And it responded in Markdown, but I'm not formatting it. I'm not formatting the Markdown, right? So if we look at the HTTP requests, it's actually not. So if we look at the HTTP request, we can see that earlier, this is where we stopped when we downloaded the Llama 3.2 model. It actually did a pull to download it. And then you can see some of the details of what it does. Like invoking all of those like math libraries, SIMD for faster calculations and all that stuff, right? And then you can see the model. You can see that it was produced from PyTorch. It supports these languages and so on and so on, right? And then this is the actual request that was made. So let me ask it something else. It's like, what can you do other than that? Yeah. Okay, so it's I made the UI simple, so it's just gonna erase the previous response and swap it with the new one. Okay, so it has your. Okay. So any question on this? Okay, so let's continue. Okay, so this was Llama running, and let's see. Let's go here in my notes. So let's see. Okay, so the same way that we install Olama, we can also install Llama CPP, which is also very simple. So I've done it before, but I'm just going to show you. Do install.
I've never heard of Olama CPP. What is that?
Okay, so Llama CPP, let me go back to the previous. Okay, so earlier when I was discussing this graph, I mentioned that there are some tools that help to convert from one format to the other in a way that's very portable. So Llama CPP is another one of these libraries. So this is the repo for it. So let me share it. So switch. Actually, let me see here. Okay, so Llama CPP, you will usually find this extension. And the extension, I think, is based on the name of the main author, like this guy. So Llama CPP is several things at the same time. It provides like yet another format for those same models, those open source models, a format which is portable. And then at the same time, it does it's used to do the process of quantization, which is that for example, in the case of the large language models, they come out with a lot of parameters with high precision, like with high precision in terms of the floating points being used. And when it comes to the inference, the more precision you have in the weight, the more resources are required to perform the inference. So to make it cheaper to run, there's a process called quantization, which slightly decreases the accuracy of the floating points so that it requires less resources. And then and it does it in a way that it does it in a way that the model doesn't lose much of its performance. So a good analogy I can give is when we talk about the audio, there are some audio formats which are very big and contain, like all of the details of the music, for example. But we also have MP3. So MP3 actually removes some of those extra details that the human ear cannot really like tell apart, right? So to us, it still sounds great, even though it's a degraded version of the audio. So with the same idea, during the quantization process, there's a lot of details that can be removed without losing much of the accuracy of the model. And then as a benefit, it's cheaper to run and smaller, right? So that's what Llama CPP does. So it has this format. It helps to perform the model quantization, and then it's also an inference engine written from scratch in C++, right? So, I mean, it does it so well that it has been adopted by Hugging Face to easily distribute a lot of those open source models, right? So, for example, this is an instruct model. I think that can be used to maybe to perform some fine tuning and stuff like that. So it's several tools in one. I mean, I shouldn't say tool. It's a project that does several things in that space.
So do we have to install it with Olama, or we can just install it by itself?
We can install it by itself.
Okay.
So that's what I just did here. Right? And then once it's installed, it comes prepackaged with a server as well. So we can do Llama server. I forgot what this one. I forgot the command. I have to look at my history. Story. Okay, so here. Okay, so here what it does, to explain quickly, is that I'm running the built-in server from Llama CPP. That server, just like we saw with Olama, also implements the Open API spec from OpenAI, right? So what that means is that all the OpenAI clients should also work with Llama CPP, right? So in this case, it's downloading the model. You can see with that the model with that extension, that .gguf, right? And then the -c, this is to specify the token size, right? So in this case, it's 2048, right? So in this command, it's going to download the actual model file, which is hosted on Hugging Face, and then use that file to run it with a context window of 2048 tokens. Okay. I've run this before, so it's starting fast because it's already downloaded. So the server should be up and running. So we can try it out as well. So let me see the controller. So here I have to swap from what? Okay. So just to verify. Okay, so same thing as we saw earlier. We just override the URL, and it doesn't accept any API token, and then we specify the model, the same one you saw in the terminal, the GGUF. Then it's this in the same manner. I'm just processing the response stream and then flush it to the client. Okay. So let's go. So this time around, it should say something different. Okay, so you'll notice that it's different than what appears is different than the Llama 3.2 that we run against the Grok service on Grok Cloud. It's also different. The response is also different from the one we obtained from Olama. And so it kind of like tells you that it's not using the same thing behind the scenes. And then here, this is what I wanted to show you earlier. Every time I receive a bit of the response, I can print what's actually coming back. Right, so you can see the choices and then the content. You see, like we have one of the words here, even. So if I search for even, so it means that it's this chunk. And I think the next one is, let me see, conversations, right? So it's almost coming back like a word at a time, right? And after it's done doing this, after it's done doing this, then I'll go ahead and print the final response. Right, and then here you can see the full text, as it was printed here. How can I help you today? And then if we look at the API calls, we can see the post request that came through, right? Then we can see some of the details of about the models when the whole process started. And you can even see the question, how are you, blah, blah, blah. Okay, any question on this?
So if I understand this correctly, Olama and Llama CPP, you hosting it currently technically on your computer.
Yes.
And then you're running it. Now, the part that I was a bit confused was the other company that also use Llama CPP to distribute their stuff. So is everything free? Or do you have any integration that is like paid?
No, those models are free. I think the part where they might have some restrictions.
Like
So here I'm just using a tiny one, 1 billion parameters, right? Earlier I tried downloading the 3 billion parameters, and right away Hugging Face basically asked me to log in and also like give a lot of details about myself, as well as how I intend to use the model. I think they do it for both licensing reasons from the entity, in this case Meta, that created the model, as well as security reasons.
Gotcha.
Right?
Yeah.
So as long as you comply, and your use case is within reason, it should be free to run.
Okay, thank you.
So that's exactly the point I was making earlier. These models, these open source models are free to use as long as we comply with certain restrictions regarding licensing and security, right? So since we can easily download them, right, and run them as you just saw, like on the local machine, it means that it's technically doable on a virtual machine that we control, right? So let's say, what if we wanted to package these open source models into Docker containers that we can ship to Google Cloud or AWS and so on and so on, or even on-prem, like if you have access to enough resources to run them, right? So, and also depending on the use case, if you have a use case that's not too demanding in a way that will require a much larger model, you can get by using these without having to pay every time you make an API call.
Yeah, that's pretty cool, to be honest.
Yeah. Any other thoughts about this?
Maybe the overall system requirement to run something like that.
Well, this one will depend on the model. The smaller the model, the less requirements it will take. I think I'm just guessing, but because I haven't done it yet, my guess would be that some of those models I just showed should be able to run within like 4 gigs of RAM. And if I'm not mistaken, they should even be able to run without a GPU.
So, like, can we say that can run on the Raspberry Pi?
Yes, I think so.
Okay.
There are definitely people who deploy these LLMs on Raspberry Pis, on phones and stuff like that. Okay, so let's continue. So let's take a quick look at how we could package, let's say, Olama inside a Docker container. So there's 2 things I want to do here. I want to show you one way of doing it with Docker containers, and then another way of creating those same containers, but this time using infrastructure as code, more specifically Dagger. So let me share the link here. Let's see how far we get. So Dagger is it's a new tool. I mean, it's been around for at least two years. I want to say maybe 3. It's by the original author of Docker, right? I think that's his new startup, and basically it lets you write your CI pipeline in one of the supported languages of your choice, right? So obviously you can write your CI pipeline in Go, TypeScript, Python, and a few other languages, but the underlying engine itself is agnostic, right? Because what these languages do at the end of the day to script the pipeline is that they make GraphQL calls to the main engine of Dagger, right? And that main engine behind the scenes is running BuildKit. So BuildKit is the part of Docker Desktop and other similar tools that's responsible for creating the layers in the Docker image and stuff like that, right? So it's built on the same technology, BuildKit, right? So I've seen some demos where if people do not want to write code for their pipeline, they can just create GraphQL queries and find a way to like curl it to the main engine for execution. So check it out. It's a very, very cool project. For some of my personal projects, I've started using Dagger to not only script my CI like with Go, and okay, let me rephrase it. So I use Go and together with Dagger to script my CI, and then I started also using Go with the Terraform CDK to script my continuous deployment, right? So it makes it so that I'm able to write all of my CI/CD just using Go. And this tool is not like that doesn't live, if you want, outside of the regular practices that we have. I know some companies or teams or even projects, will use like stuff like Jenkins or GitHub Actions or GitLab CI and so on and so on. It has some facilities to be able to run in any one of those existing tools. I think you can see some of them here on the left side. Right. Okay. Any question on this? Okay, so let's see how far we get. So I want to be able to package the Olama model, the same model that we run inside the Docker image, and then try to convert that Docker image into a CI process with Dagger that we can use to publish the image on, let's say, on Google Cloud Registry. So let me copy this. This is a good profile. I'll just call it this. Profile Olama. So let me split this one. Yeah, I'm actually running Podman, but I created an alias, but it's the same thing. So I can do Docker builds. I think that's so let me target. So let's call it Lama. Okay, let's see what happens. It's running slow. I'm not sure why. Okay, let's give it a minute. If it takes too long, I'm just gonna show you different projects, like basically how we can move from a Docker file to Dagger. It shouldn't be that slow. Maybe it's because I'm streaming. It's Any questions in the meantime?
I have it's more of a question, a general question, but I was gonna wait until the end to ask, but since we have the time now, let me go for it. So as somebody who just graduated, let's put it that way, and is looking into the tech world right now, hearing that companies are hiring people with AI experience, and companies are no longer hiring, techs and all that. So where should I focus on when it comes to AI so I can be valuable to the world out there?
Well, I think the place where you can be valuable right away is to, in my opinion, first learn how to use these tools like efficiently. For example, for the longest time, like I was a big critic of all of these tools that help people write code, right? Because to me, like it prevented them from like actually learning the craft, which is disadvantageous. Because in certain scenarios, due to licensing and some restrictions at work, it may not be even possible to leverage these tools. Given the fact that for LLMs, it needs to be prompted with some information or some context window in the form of RAG, in order for the LLM to provide good responses. So this could be like sensitive company data going out to some random cloud service, right? So in these types of scenarios, we cannot use them. However, there are some use cases where they can actually be useful. Like I'll give you an example. Like let's say, like like my JetBrains IDs on my home machines, I have GitHub Copilot, right? So it does all of those things with auto completion and all that. Right? Most of the time, I find it annoying, and then at times I have to shut it down, especially when I'm writing new codes, because it's not helpful at all. But I've discovered a new use case this week using Claude. Not something that you will run in your IDE, like per se. It's more like a workflow that they design in the Claude app online, in which you can do some sort of like inversion of control, in the sense that instead of you telling the LLM what you want and expect it to get it to 100% of the time, you basically turn it into something that asks you questions that you have to answer in order to clarify what you want. And I don't know if it makes sense. So
Yeah, it does.
Yeah. So the workflow they designed is that they came up with something called a project. Actually, let me see here. I'll go to Claude. Am I logged in? So if I go to, okay. So I was trying some, for today's topic, I was trying different ideas, right? So here it was a completely different workflow. So I can show you something. So this one here, this first prompt has to do with refining the thoughts. Basically, I tell it that I'm gonna tell the LLM about some ideas that I have, right? And why I want to implement those ideas, what's my goal, how I want to do it, the type of technology I want to use. And then this thing keeps asking me questions to clarify until it feels satisfied with my answers. And then it lets me come up with a plan. Right?
Okay, like brainstorming.
Right.
Slash coach.
Yes. And then the nice thing is, once we have the plan can be stored as part of project knowledge. So this is where your RAG will come in, right? So since it's part of the project of the overall project knowledge, any other conversation I have within the scope of that project, the answers from the LLM will take this information into account before answering, right? So what I had done was that I provided it with a schema, right? Here I'm using a format called Q. Maybe I can cover it another time during the presentation. It's a shorthand for defining schemas and restrictions on data, right? So I provided it basically as a concise way to tell it about the data model for which I want to create some apps, right? So it's also in the project knowledge together with the master plan. And then in here, it helped me not create code, but it helped me create, if you want, like a directory structure, right? So the directory structure, like basically, I told it in the master as part of the master plan, which UI framework I want to use, which backend framework I want to use, the data models and all that, and then it came up with this directory structure, right? And then based on that, I can also save that project structure inside the project knowledge, and then proceeds to brainstorm about specific implementations of each one of the files in the project structure, right? So there's this back and forth, right? Where it helps me, like, if you want, brainstorm or bounce some ideas, like quickly, so that I can narrow down to exactly the stuff I want to build and then go ahead and build it, versus what I've been doing for the longest time, which is to just brainstorm and think, okay, maybe I should do this, and then realize, like, 1 week later that I took a wrong path, and then scrap everything and then start over a different way, and then another way, and then another way until I get it. So here I can speed up that process of design and thinking, to a few minutes or a few hours, and then when I actually start coding, it's more focused. So I don't know if it makes sense.
Yeah, it does make sense. But it does not like fully answer the question about looking for a job, right? Let's say as somebody who just graduated, and then you hear companies say, "Oh, if you use AI, you can get fired," and you hear other companies saying that you might lose your job in the next few years if you don't know about AI. Now you're confused. What part of AI do I need to know to be useful? That's the question itself. I know you touched a little bit of it, which is like the learning the tool, knowing when to use it, but also knowing what kind of data you should not put out there. But the reason why the question came up is also because you started talking about the self-host um, languages, right? Or like infrastructure that we were talking about. So is that what people are looking into? Or are these companies looking for like engineers that can actually build AI tools?
Well, okay, so at least from my experience, companies, you at first will try to use off-the-shelf solutions. Like, let's say if they want to run Llama, they will pay AWS to run Llama for them. Or if they wanted to run OpenAI, they will pay Microsoft to run OpenAI for them. But then, as soon as they realize that the price is becoming an issue in terms of how much they spend, they start to look for solution to decrease their bills. And that's where they will look for engineers that know how the sausage is made in order to help them cut costs. Right? so as your role, like in your role as an engineer to solve problems, for clients, companies, and so on and so on, you have to be like play on both sides, figure out how AI can help enhance your workflow, and actually help you save time in your learning and your practice, not replace what you do and delegate it to AI. This fundamental knowledge, you want to obtain it and keep it for yourself. So I mean, it's a bit of a hard question, but the thing I'm sure about is that you want to have and gain as many skills as you can and as quickly as you can.
Okay, thank you.
Yeah. Okay, let's see. Any other questions?
Why the age of AI?
Why the age of AI?
Yep.
Well, because, in a way, AI is affecting, if you want, the whole industry, because to be competitive in that space, in a way, all of the different skills and responsibilities that used to be siloed, like there will be like the DevOps guy over there doing his thing with AWS. There will be the software engineer here trying to finish stories, by the end of the sprint, the designer over there trying to do something else. Like everything is coming together like closer than before, under the AI umbrella, because building a smart app is not just calling an API, right? There's a lot of concerns about resources in use, user experience, cost, functionality in the solution, and so on and so on. So the collaboration, as I see it, is becoming closer, and since AI can help make some of the work efficient, like for at least like brainstorming, like I was showing you earlier, I'm guessing that soon we're gonna start seeing some roles that cross the boundaries between all of those areas that seem to be siloed. So DevOps is definitely one of them. So.
Thank you.
Okay. Yeah, so I have a question, a pretty general question as well. I'm struggling a little bit with the concept of parameters. So can I look at them like if I'm taking a table, I see parameters as columns?
I don't think so, because the file formats for the models I think are compressed. I don't think it's really meant to be like read. Listen. Plus, even if you can read it, I don't think it's gonna be intelligible, because it's just numbers, a whole bunch of numbers compressed together. To have an idea about the model itself, there are some tools that can plot some visualizations of how the different nodes in the network, are put together with their with the sizes of the different layers and stuff like that.
Okay, another
But I'm
general
curious, why would you want to look at the numbers in the model, like the weights and everything?
You ask me?
Yes.
No, I'm not trying to look at the numbers. I'm trying to conceptualize that, because sometimes I hear like 1 billion parameters, 5 billion parameters. So I'm trying to see. That.
Yeah, because if you understand how the models work, let's say like when you go to ChatGPT and type your prompt, the model itself doesn't understand text as you write it. There will be a process behind the scenes to turn the text that you typed into numbers, because that's what the model deals with. And then the numbers will be used for further calculations. And then the model will output some other numbers. And then these numbers that come out as a result will be passed through another process to convert them from numbers back into English that you can understand. So
Okay, let's take for example, if I ask GPT to write, or LLM to write, let's say like a text, whatever, a summary or something. So what would be the difference between using a 1 billion parameters and like 3 billion parameters? Can I notice that in the result?
Well, like basically the more parameters you have, the more the more knowledge the model has in a way. Because okay, one way to try to visualize it. Let me see if I find a graph here. Okay. I forgot the name of this thing. Okay, let's search for structure. So clustering. Okay, let's take this one. Sorry, I made it worse. Okay, is this visible?
Yes, it is.
Okay. Okay, so if you imagine that the model itself is like a plane, like a space with like different numbers, different dots. Like try to imagine it like in 3D space, right? When you query for something, the inference engine is able to figure out how close the answer is to a certain domain based on like what you typed in your prompt. So let's say if you are asking the model about ice cream, the model knows from the different weights and numbers that the ice cream area is somewhere over there, right? And like we saw earlier, when we look at the response, let's see, I think it was LLM. Is it this one? No, I think it's the controller. Let me close this one. So like we saw earlier, the responses we never actually get one response. We get a number of responses. Let's say like 5 or 10, and 0 is the index of the response that has the highest percentage of being correct, right? So let's say when the model answers you about ice cream, there's a whole bunch of dots in that space, right? But one of those dots may be the closest to what you are actually looking for, and then for good measure, it's also going to pick some other dots in the area and then send it back as a result. So these numbers just like we see the x-axis and the y-axis, all those weights that you will hear about, those are pretty much coordinates. So when you type your prompt, it turns your prompt into coordinates, and then the inference engine tries to figure out how close it is to something it already knows. And then based on some on how the network has been assembled, it can pick a number of dots as answers and then turn them back into English for you. That's kind of like how it works. That's one way of seeing it. So the more parameters you have, the more clusters you have. Let's say in a 1 billion model, you only have 2 clusters. You have ice cream, and then you have sodas. So if you start asking about dog, it may not know. But there's a good chance that the same model containing 400 billion parameters will definitely have something about dogs. It will have a dogs cluster somewhere over here.
Okay, I think I got
Okay,
it.
I see. Thank you.
Yeah. So the bigger, the better, but it costs more. Costs more to run. I mean, this is not financial advice, but if you intend to start buying some CPUs, maybe buy some stocks from NVIDIA to to compensate your spending.
You say CPU or GPU?
GPUs. If you start buying some GPUs, like buy some stocks from NVIDIA to offset your spending. So.
That's true. Okay, more of another general question, and maybe now that I'm thinking, this might be something to bring up in the Sunday meeting, the coffee meetings. So let's take a step back at the internet time, right? When it first started, everybody was, pretty much into the race. And then we have somebody like Jeff Bezos who actually, came up with Amazon and now is the biggest. With the era of AI, where do you guys think the next big thing is gonna come from? I know this is more of a prediction, but I'm just picking up brains here.
Yeah, anyone want to jump in to answer? Well, I mean, I can give my opinion. I think I mentioned it last time in the conversation I had with Aziz. My thinking is not really like about the next big thing. It's more like more and more we're gonna find AI in more places, especially places that deal with digital information. So it doesn't matter if it's your phone, your computer, or even like an ATM machine out there. Like all the use cases that you can think about where you have to retrieve some information and think about it, and you may have questions and stuff like that. Most likely AI will come into that domain and make it more efficient. So to the point that that's like in a few years, maybe like some problems and challenges that we deal with today because we are overwhelmed with like too much information, it's all gonna be streamlined through AI. That's what I can predict.
I see. My own prediction is content creation. I think the power that AI puts in the hands of individuals is, to a big scale, and then it will allow, people to actually be really creative and all that. So any company that might be able to actually put that in one place where content creators and artists and all that can actually showcase their work might actually be the next big thing.
Okay. Like, can you expand on that? Like, what do you mean by creative?
Yeah.
Like,
So let's say I am an artist, right? And then I'm really good at doing some paints, but there's and other things that I'm not good at. So if there is a tool or like there is a platform that allows me to showcase my work and make money while not having to worry about, let's say, the the finance part of it, not worry about running the business, not worry about all this stuff. But I can actually do my work and still make money without hiring a team, without having to worry about I need to talk to a venture capital to raise funds and all that stuff. That's what I'm talking about.
okay, I see. Yeah, but I think there's a bit of a challenge with that as well, because the fact that most of the best performing AIs are not um, are not open source, and are accessible to everyone through a small fee. Like how what's going to constitute your competitive advantage in that scenario? Because 10,000 other people can have the same idea and leverage AI to do similar things. So how would you like differentiate yourself and come out on top?
Yep. So that's what I'm saying. The next big thing is not actually the person creating the content. It's the company that puts all these people together. So do you understand what I mean? So imagine there is a platform that gives you, all you have to do is just come up with an idea and then get it out there. And then everything else will be handled for you, all the way to sales. Now, if you have another person competing with you, that's on you guys. It's literally like the race to gold, right? And then the guy who creates the pickaxe. So that's what I'm talking about. Like for the next company, the next big company will be the one that will put the space for everybody to actually be able to spin up businesses quickly, make money, and then if they want to walk away, they walk away. If they want to stay in the competitive world, they can stay there.
Yeah, okay, I see what you're saying. Yeah, there's yet another thing to think about too. If this company that you are thinking about is leveraging AI, they had better be the ones who created that AI itself and control it. Because if they just leverage, let's say, like ChatGPT, it's only a matter of time before OpenAI itself comes up with a similar product, and they don't have to pay for inference. It's free for them to use in a way. They can easily put that company out of business. That's what I'm trying to say.
Yep. Yep.
Yeah. Any other thoughts or questions? Anything?
No question, no question for me. That was good.
Okay. Yeah. So yeah. So I think we're gonna do probably a part 3 for this one. Yeah, because time goes by so fast. I actually had some other workflows that involve AI, because what I showed you so far was how these models are created and saved to disk, how we can reuse them as part of our own infrastructure. That's what we saw today. But there's also a third use case in which the model itself can be integrated inside the CI and CD process. You know, even probably when we do ops. You know, so by that I mean that let's say you use Kubernetes, right? You have all of those kubectl commands that you type over and over again, but you usually type them for a reason, right? So there are some use cases where we could directly tell what we want to happen in the cluster, and then the AI itself can take that natural language query and turn it into, let's say, like Kubernetes actions, you know, like checking logs, checking the health of some pods and stuff like that, you know. So we could do a part 3. That's what I'm trying to say.
I think that might be a great idea too. Thank you.
Yep. Also, there's nothing else. I think we can wrap up for today.
Thanks again for sharing your knowledge with us.